Welcome all participants for attending this program. Today we are going to discuss about electrical safety audit. As Mr. Dominic told, what is the meaning of audit? We will see a little bit in detail today. Hope my sound is clear. Also, thank you. To start with, last few this is I think our in last 1.5 years or from since 2020 June. This was about 140th or 142nd program. Nowadays I stopped counting. Also along with blue and gray, this is I think about 30th program which we are doing for the last.
And we have covered almost 8,000. Today I was just calculating number of people who are participated, the database that we have, almost 8,000 to 9,000 people are attending this our programs. And today, Gopakumar, just for your information, we have 830 registration. Like last time we did on Sunday, that also crossed 800 participation. And today being Saturday, working day for some people, we still have 830 participants. It's very encouraging, very inspiring for us to do more and more. Thank you.
Yeah, thank you. And I think about 250 participants are already watching this program, plus on the YouTube and other social media. Now, anyway, let me go to the subject straight away, electrical safety audits. Before starting the program, a small introduction. You can see a new logo now. All of you are, those who are participating in our programs, you know very well that we were doing Vidyut Surakshit Bharat Abhiyan, which was a highly successful program. We could attend, or there were about 25,000 plus attendees in this program, which was conducted for almost 1.5 years. Now, we get a lot of requests to do something for electrical safety, and there was a noble idea given by engineers of electrical inspectorate. Also, one moment, I have to hide the panel, hide floating meeting. Oh, yeah. Also, let me switch off my camera because sometimes with the camera it's very difficult. Yeah. Okay. Now, with the support of the engineers from Electrical Inspectorate, CPWD, PWD, Defense, Railways, and industries and private sector, there were a lot of demand or there were a lot of requests to start some kind of an association so that everybody can be involved in making a safer India. As a result, we were trying to register an association as a society. So that all these activities can be, the knowledge sharing or the skill development activity can be carried out further. So we registered the association, NFE, National Federation of Engineers for Electrical Safety. So we are setting up the website, we are setting the other goals, vision, mission and goals of this particular the association. Probably within a week or within 15 days, we will come back with more news on the National Federation of Engineers for Electrical Safety. We have great plans, and also the trainings which were carried out under the name of Vidyut Surakshit Bharat Abhiyan will be now taken over by National Federation of Engineers. We have there are about 13 founding members, starting with Sri Apau, retired Chief Electrical Inspector, Tamil Nadu. Also, Mr. James Kuti Thomas, retired from Kerala, plus engineers from CPWD are there, engineers from railways are there. So with their support, we could register the association and we are starting the activities. Now, going to today's subject, challenges in electrical installation. You must, all of us should understand that an electrical installation, once installed, changes are difficult and sometimes rarely changes are possible. If you install, if you put a conduit, pull the wire through the conduit, fix it inside your concrete, that's it. You cannot change it further. If you wanted to change it, this becomes a major work. Similarly, in an industry, if you pull the wire through a chamber, then it's very difficult to change. So once installed, the changes are very difficult in an electrical installation. This means when you do the job for the first time, you have to be very careful and you have to do it perfect. In several applications, switching off for the purpose of making a test is impossible, or sometimes it's very difficult. Say, for example, in a hotel, if we wanted to make a periodic verification, or if we wanted to switch off the supply and make an RCD test, for example, sometimes we have to wait for a few days. They say the rooms are occupied, there is no room left out, and we have to wait and spend a lot of time for doing this verification. Similarly, in a hospital, switching off the power supply and making a testing or verification is almost equal to impossible, very, very difficult. So this also shows that while doing the job at the first time, you have to do a perfect job. Several parts of the wiring are hidden and inaccessible. All of you knows, if we look at our house or our office, you will be able to find out that most parts, say for example, you have a false ceiling, and above the false ceiling, we really don't know how the wires are routed. If you wanted to check it, most of the time it's impossible, because it's already, you have a false ceiling and you have to damage it. Very difficult. The fourth part is the connected load, and its technology are rapidly changing. You know very well that earlier we had air conditioners, now we had air conditioners with rectifiers inside. That means AC-DC conversion is happening, inverter air conditioner, inverter refrigerator. A lot of semiconductor-based devices are coming into the picture. Earlier it was the incandescent lamp, then tube light, then CFL, now LED lights. So each of these devices, the way it operates differs. Say, for example, modern devices are creating more and more harmonics. They are switching, and the multiples of the fundamental frequency are sometimes creating more issues into the line. Similarly, increase in load. Once when we start an electrical installation, we think that, okay, we are going to have X amount of load, but after some time, we need to increase the load. So this is also a challenge, but you please note that in developed countries, rather than increasing, the load is decreasing because of energy efficiency, because they already have a maximum number of electrical appliances connected to their electrical installation, and now they go for more and more energy efficient things. As a result, the load is actually developing, whereas in our country, the load is actually increasing. Change of consumer to prosumer. So far, we were utilizing or using electricity, we are consumers, and now we slowly change to prosumer. We are going to have new kind of electrical generating systems in our roof, sometimes solar PV, sometimes small wind, or a lot of new technologies are coming up. The system which were working in the earlier situation may not work in the new situation. Say, for example, you have a TT system earlier in your house which was working for example, for quite some time. Now, if you wanted to change or if you wanted to add solar PV into your network, sometimes the same network, solar PV, will be very difficult. It may work, but the question is whether it will work safely or not is the question. It may not work safely. Another challenge which we always face is the black box solution. What I mean by black box solution is, first we should understand that electrical safety is not about a product which can be brought from the market. Like, I want 10 kgs of electrical safety, or I want 5 numbers of electrical safety. That kind of, this is not a product which can be brought and installed in your system. And there is no one product available in the market which will make all your installation safe. If somebody says, I have a product which will make the entire installation safe, please note that this is almost equal to impossible. Whereas if we look at in the market, you will get a lot of black box solutions who claims that my black box is the ultimate solution for all the problems, all the daily problems which is faced in the electrical safety scenario. Sometimes One of these classic example is, say, for example, all of you know very well, all electrical engineers know very well, chemical earth. So chemical earth has been projected as a solution for all your problems. This is I would say, a black box solution. Nowadays, the chemical earth people, the companies those who are involved into chemical earth, they started changing the name. Somebody call it as alpha earth, somebody beta earth, somebody sigma earth. Everybody claimed that I am the world's best, or India's best, or Asia's best, and all these claims. Somebody says my earth compound grows capacitor inside. As a result, it gives a much better value. So black box solution, basically what I mean to say is black box is a solution which says basically a foolish idea and with exaggerated claims. Black box is referred to have unscientific products with exaggerated claims. So this is a big threat in the industry. Some of the examples we can also see, for example, digital grounding device, which is quite common in the industries, especially in telecommunication and instrumentation industry. Black box, the digital grounding. This is actually a highly dangerous equipment. This digital earthing system creates a TNC network in your building, which is actually illegal. Very, very, very dangerous. Now, the next point is the normal persons work in locations where skilled or instructed people are required, or sometimes supervised by skilled or instructed people. These are actually missing. A person who doesn't know much about the subject is working or sometimes handling an electrical apparatus. This also creates a hazardous situation. Say, for example, opening up a panel board inside which contains some live parts, and without proper PPE, somebody putting a screwdriver into it and ending up with trouble. So these are also creating some of the issues. I have put only 8 points, but if we start putting the number of points, you can find out probably 100 reasons for where we violate electrical safety. So due to these reasons, which is told in the previous slide, any compromise in design, erection, and the initial verification, it can create a serious safety and reliability challenge. In the sense, after installation, you cannot change it, you cannot switch off, you cannot go and test, you cannot access the wiring. So don't compromise in the design, in the erection, and in the initial verification of your electrical installation. Because if you have a perfect electrical installation, it will serve for at least 40 years or 30 plus years. Now, to enhance safety, what we do is safety audit. The word safety audit is very interesting to understand. Please note that audit is a checking, sample checking. Sample checking in the sense you have 100 circuits, you check 3 circuits on a sample basis and you make an audit, or you check 10 circuits and you make a safety audit. This actually is illegal as per the standard. The standard IEC standards never use the word, or very, very rarely use the word safety audit. The word which is used in the standards are always verification. As an example, I will show you from some of the standards, just to show you how these standards are written. I am showing you the standard called as 61936 Part 1. This is also becoming an Indian standard. Power installation exceeding 1 kV AC and 1.5 kV DC, Part 1 AC. This standard is talking about the electrical installation above 1 kV. I am just searching. You can see on the right side in the find, I am just searching the word audit. You cannot see any word audit in this particular standard. Whereas if you look at the word verification, you can see verification is quite common verification. Approximately 21 places in this particular standard, the word verification is used. I'm just showing you also the standard IS 732. All of you know very well. Nowadays, we talk more about IS 732, Code of Practice of Electrical Wiring. This is the Indian standard. And now here also, I am checking the word audit. There is no word called audit in this particular standard. Whereas if you look at the word verification, it is reflecting in almost 77 places. 77 places verification is written. Similarly, I'm showing you the standard for lift, the ISO standard for lift. So audit is never there. Only audible word is there. Audit is not there. Whereas if you look at verification, verification, verified verification, there are 24 places verified is used, 18 places verification is used. Next standard, lightning protection standard 62305 part 3. I'm sure all of you know about this standard as well. Here, let us search for audit. Of course, no audit, then the word verification. So verification is used 4 places in this particular standard. A maintenance program should contain provision for the following: verification of LPS conductors and system components, verification. So always the word which is used is the verification. It is not the audit. So once when we read it, we have to be very careful in understanding this. I am also showing you the standard from about UPS. Let us search the word audit. No word called audit. Verification. Verification is used 13 times in this particular standard. So basically what I wanted to tell you is the word audit is actually not applicable for an electrical installation. Instead, what we have to do is verification. Audit is a sampling process. A chartered accountant makes an audit. He don't go through the entire accounts. He checks on sampling basis. So whatever we do on sampling basis can be called as audit, and whatever we do thoroughly. For example, fire safety. It's not fire safety audit. It is fire safety verification. So please refer to the necessary standard. You will be able to understand the meaning and the complications of this particular standard. The difference between audit and verification is, in a verification, you are supposed to test, inspect and test all the points. In an audit, not all the points according to your convenience. So the auditor can decide the amount of things which he is supposed to do, whereas in a verification, he doesn't have he cannot make a decision. He has to go as per the standard, because electrical or fire installation, we are talking about safety of people. Say, for example, in a safety audit, in an ISO 9001 audit, for example, if you find 2 non-compliances, you can rectify it later on. Whereas in a safety audit, if you find 2 non-compliances and if you try to rectify it after some time, within this time, there can be an accident. So safety verification is the correct word. So electrical equipment and the installation need a verification during its design, erection, commissioning, and periodically. It's very much important. Not only during the product testing, verification is required during design of the electrical installation, erection of the installation, commissioning of the installation, and periodically you should do verification. The other word which we use, say for example, you have a motor. Before selling the motor, the manufacturer is making a type test. So that is a totally different thing. It has nothing to do with verification. There, the motor is tested to find out whether it is in compliance with the standards. So with this background, let us start to use the word verification. What do we do actually in safety audit? In a lot of places, especially in high-rise buildings, especially in IT offices, electrical safety audits are carried out as per NFPA, which is an American standard. Sometimes the British standard BS 7671 is used. most of the time, the auditors are not aware of the Indian standard. Please note that equivalent, better Indian standards are available, and you should follow the Indian standard for verification. Mostly the auditors, I don't use the word verification here because conventionally we are only doing audit. We don't have the habit of making verification. Conventionally, the auditors are doing some kind of physical check. They run around the installation, they walk around the installation, find out whether any hanging cables, dust on the panel boards and so on are there. Then they check the availability of general condition, availability of PPEs, signboards, circuits, charts, tables, and so on. Plus, in some cases, the load flow analysis is also made, like the used power, the reactive power, and so on. But please note that load flow analysis is not a safety subject, it is something else. In almost all the electrical safety audits, testings are carried out. I have put 3 testings which is generally carried out in the case. Not all the 3 are generally carried out. The first one, earth pit resistance, the resistance measurement of the earth electrode is always carried out. The second one, IR, insulation resistance, which is not done very carefully, but sometime the IR measurements are done, insulation resistance, and thermography. In modern buildings, thermography is done because people believe that by making a thermography, you can achieve safety, which is absolutely not 100% correct. Also, I put underline 2 things: the earth pit resistance measurement and thermography. Please note that the earth pit resistance measurement has been removed from the low voltage electrical safety standards a few decades back internationally, and even in the IS 732, if you look at the 10 testings, the earth pit resistance measurement is not mandatory. The technology is already changed, not now, 20 years back. Similarly, thermography is not a recognized test or recognized verification mechanism in the standard, which I have shown you earlier. Those standards. Thermography, of course, for solar PV, yes, you can do that. But for an electrical installation inside a building, thermography is not recognized until now. So what I wanted to tell you is, at the moment, under the name of electrical safety audit, we do something. The question is whether they are really helping the improvement or helping any improvements in the consumer premise. And most of the cases, more than 70% of the cases, please note that I have been getting questions from hundreds of customers. The safety audit reports are being shared with me. I am reading the safety audits and I'm responding back to the clients. And most of the safety audit reports which I see, more than 70% cases, additional earth bits and chemical earths are recommended. And the sad part is, it's always recommended as per IS 3043. As a member of ETD 20, I know very well that this chemical earth or this additional earth bit is not going to help you. So if anybody wanted to recommend chemical earth bit, you recommend, we have no issue. But the problem is, don't claim that it is as per IS 3043, because IS 3043 never written in this fashion. So in fact, this chemical earth or these additional earth bits, it's actually a violation of the standard. So by looking at the safety audit reports, what we feel is Indian standards are required or Indian standards are referred only to violate, whereas all the other standards as per NFPA, BS, all these things are mentioned in the standard. The client most of the time doesn't know what the NFPA says or the BS standard says. Actually, all these wordings, high wordings like NFPA, BS and all, these are like, big names so that people are convinced easily. That is actually not necessary. Coming back to the rules and regulations of India with respect to electrical safety, all of you know that we are governed by the Electrical Safety Act 2003. Electrical Safety Act 53 says the CEA shall make the regulations for the purpose of the Act, and in regulation in the Act 146, punishment and in 49, offenses by companies. All provisions are very well explained in the Act. So that means if somebody violates the electrical safety, there are provisions already available in the Act to punish the person. Who has to punish? Of course, it has to be initiated by the appropriate authority. So most of the time, for example, these punishments are not carried out properly. Say, for example, the regulation very clearly says the overhead lines should have guarding, so that in case a line cut and falling down, people are not getting affected, especially while road crossing, especially while railway track crossing. But you cannot find a guarding in our overhead lines. It's an offense. So very simple, the electrical inspector can straight away take a case against the electricity supply company, and they can be punished not for having this safety measure. But who does it is the question. Now, coming to the central CEA measures relating to safety and electric supply, of course, I am referring to the proposal 2022. I don't know whether it will be finalized or not, but the same proposals are there since 2016 or 2018. So, save otherwise provided these regulations, the relevant Indian standards and National Electrical Code or National Building Code shall be followed. So basically this part, what it says is whatever not contained in the regulation, you can refer to the code of practice of Bureau of Indian Standards to achieve safety. That means the regulation is mostly discussing about generation, transmission, distribution, and up to the point of commencement of supply, mostly up to the point of commencement of supply. Of course, there are regulations which is applicable for inside the house as well. So whatever the subject not covered in the regulation, you can refer to the code of practice. And for example, one of the regulation which is talking about within the consumer premises regulation number 36 earlier. Now in the new proposal, it's regulation number 38. It talks about the owner or occupier of a multi-storied building shall ensure that electrical installation and works inside the building are carried out and maintained in such a manner as to prevent danger due to shock and fire hazards, and the installation carried out in accordance with IS 732 and National Electrical Code. Provided that hospital and medical establishments shall have safety measures as per National Electrical Code, irrespective of height. So probably, this is a new information. The new regulation says that you should carry out your design, erection, and installation as per IS 732, or compliance to IS 732 is becoming mandatory in some of the buildings, especially the high-rise buildings more than 15 meters height. Also, the regulation, I think the number is 6, talks about the chartered electrical safety engineer. Who is chartered electrical safety engineer? What is his qualification criteria, and what kind of formats he has to follow? For example, what kind of test he has to do? He has to do test as per regulation 32, periodic inspection, and periodic inspection means every 5 years you have to do the testing which is prescribed as per this particular regulation. Then precaution against I'm just showing you some of the regulation which is actually very much connected to the safety in an electrical installation. Say, for example, I have put the new number. I think the earlier numbers were 30 and 33. Now the new number is 32 and 35. 32 talks about periodic inspection and testing once in 5 years, for example. 35 talks about precaution against leakage before connection. This regulation says before you connect electricity to a consumer premise, you have to make an insulation resistance test, and the value shall be higher than 1 megaohm. Unfortunately, these tests are nowadays not at all carried out, and this is one of the reasons for accidents. Also, the regulation explains the formats. The reason for showing these formats are probably in future, people will start doing the electrical safety audit as per this particular format. Please note that this format, which is Form 2, in the upcoming regulation, actually it is talking about the compliance to the regulation. For example, in a consumer premise, you see regulation 15, 16, 17, 18. This format is asking about the compliance to regulation. And in my view, if you fill up or if you do a compliance as per this particular format, of course, electrical safety on a large scale, it cannot be. In a residential case, it's okay, but in a large building, it will be very difficult to achieve electrical safety. In an industrial or in a large commercial installation, it is very difficult. So, however, these formats are already given in the standard in order to do verification by the chartered electrical safety engineer as per the particular regulation, and the chartered electrical safety engineer also shall carry these particular meters. Say, for example, one of the new incoming is a loop impedance meter. Fault loop impedance meter is also required. But again, for a larger industrial installation or in a medium level industrial installation, these basic testing equipments are actually not sufficient enough to make an electrical safety audit or electrical safety verification. Probably you can make an audit because audit is only partial. Verification is not possible. Why I show this these tables are, there is one more regulation which I will refer a little bit later so that you will be able to understand the importance. So basically the problems are, safety measures are rarely followed, especially, for example, regulation 30, 33, 40 are violated in almost all low voltage electrical installation. Guarding is not there. The protective regulation 14, 15, 16, the earthed conductor from the supplier side is not available in most of the state governments. So these are actually attributing to the large amount of accidents. Similarly, understanding about system earthing, TN, TT, IT. If you don't know what is TN, what is TT, and what is IT, actually you cannot do a verification. You cannot. Earthing is not about putting hundreds of earth pits. Earthing is about the best way of making one of these system earthing and ensure that all the safety measures are made. So most of the time, the auditors are very rarely aware of TN, TT, and IT systems. I am making this statement because of with my experience. I participated in some of the electrical safety training organized by some international companies. Say, for example, a lot of companies, those who make international companies, those who make trainings. I attended international as well as Indian after paying the fees, but most of them doesn't have any knowledge or any idea about system earthing. They always talk about earth pit and chemical earth. So knowledge on basic, the idea of basic protection and fault protection measures are very rarely understood. Each safety auditor have their own interpretation and assumptions. Most of the time, audits are made based on assumptions, not made based on what is written in the standard, which is actually not correct. Safety standards are unknown, verification is unknown and rarely carried out. As I said, please note that I am not using the word safety audit, I am using the word verification. Verification audits are made, but the result of the audit is a question. Verification is rarely carried out. Equipment requirements are often violated. Usage of wrong and exaggerated products. As I said, the exaggerated products are like this, something called as digital earthing, something called as chemical earthing. Nowadays, most of these chemical earthing companies become electrical safety auditors. So chemical earthing company becoming an electrical safety auditor, the result is he will try to recommend 25 numbers of more earth pit. The client buys it and installs it. This is actually not correct. So now I show you a small example of, rather than talking a big safety scenario, we should always start, or my way is to start from some small things. I'm just showing you the meter board from Bombay, which is used in most of the apartments. There is a room, a meter room, and all the meters and the protective devices are mounted on the wall. The first point to note is earlier it was a wooden board which was catching fire quite often, but nowadays the wooden board is stopped and cement boards, fire resistant cement boards are used. Anyway, congratulations, it's a good thing because the chance of fire on the wood is avoided, but still a lot of existing buildings have wooden board. But now in this particular case, the funny point is the electricity supply company is using a 32 amps MCB, type C MCB at the meter board, and the owner of the builder, the apartment builder, has provided an additional MCB. Say, for example, near to the meter, there is a 32 amp single pole MCB, and these are at the top. These are double pole MCB provided by the builder, and these are 63 amps MCB. So the incoming is 32 and the outgoing is 63. Of course, the wire is not enough sized to carry this much current. So imagine a situation after a few years, due to some reason, if you bypass this 32 amps MCB until the 32 amps MCB works, it's fine. But if you bypass under any condition or if it is not working, then the chance of fire in this installation is quite normal. It can catch fire. So this is actually, it's a small thing. The builder can, instead of 32 amps, he could have given 32 amps. Instead of 63, he could have given 32 amps MCB. Unfortunately, the auditors or the electrical inspectorate engineers or none of them take care of this particular thing. And after a few years, this room, which is at the beginning a neat and a clean room for electrical meters, becomes a dump yard. Most of the time, the key is with the security. Sometimes the security sleep inside. His dress is kept inside. In this particular picture, what you are seeing is a meter board, the electrical room, which belongs to the energy supply company in Bombay. So you can see here the wetness inside the room. The security fellow told he was keeping the diesel of the generator inside this room. So what do you need more than this in case of an accident? Of course, you see a lot of fan. That means all the bus bars are hot and they have kept fan to cool it down. So such situation shall not be allowed. The electricity supply company must be asked to improvise this. If we try to continue this kind of electrical installation, of course, even after 100 years, we cannot stop fire from electricity. So very pathetic situation. So we should actually not, going to the big level of safety. We should start from such small things. And this particular building, which I am showing in the picture, it contains a multinational bank at the first floor and second floor. And when I asked them, they already conducted an electrical safety audit. So basically, this building is an electrically audited building, and the basement looks like this. Now, please note that verification always consists of inspection and testing. There are two things. Inspection means physical inspection. It is not just like you run around the place and find out something. No, there is a sequence we are supposed to follow, and testing. Now, in the new regulation, regulation number 33, a big improvement has been made. Testing on consumers installation. You can see the first part. Let me skip it. Provided that recommended testing and verification as per IS 732 or National Electrical Code, wherever applicable, shall be carried out. So now the regulation also started insisting for verification as per IS 732. Now, if the National Electrical Code is saying some frequency of verification, the audit must be carried out as per IS 732 or National Electrical Code of India. Please note that I am referring to National Electrical Code of India, not the National Electrical Code of other countries like America, because if you search on the Google National Electrical Code, you will get information only from America, whereas I am talking about NEC of India. Now the IS 732 and NEC, what do they say about verification? Verification consists of two subjects, inspection and testing. Inspection, there are about 18 points for inspection. The first one starts with the method of protection against electric shock. I made it bold because I will explain what the meaning of this particular measure. There are 18, but the first one, protection against electric shock. When it comes to testing, there are 10 testings included in the standard, whereas in my slide I have put 11 testing. The 11th one is actually PAT, portable appliance test. Probably it may come into the standard on a later stage. So I will explain you the first one, resistance of conductors. So next 2 slides, I explain the first inspection point and the first testing point, so that you can ascertain the situation of your electrical safety in your building. Now, protection against electric shock. There are several techniques. Basically, you need to have a basic protection. You need to have a fault protection. Basic protective measures are there, such as live part, barriers, obstacles, placing out of reach, fault protection, automatic disconnection, ELV, separation, double insulation. There are different techniques. For example, in our last webinar regarding solar PV, we discussed a lot about double insulation. In a solar PV, especially on the DC side, protective devices for quick disconnection, automatic disconnection is not available. For example, fuses are not efficient enough to quickly disconnect. MCBs are not efficiently enough to quickly disconnect the supply in case of a fault. There is no ELCB or RCDs available. They are still under development. There is no arc flash detection device, AFDD, for pure DC application. So basically, disconnecting the supply during a fault is very difficult. There, for the DC side of solar PV installation, we are supposed to follow a system called as double insulation. From the terminals of the solar PV up to the terminal of the combiner box or up to the terminal of the inverter, the entire electrical installation DC must be double insulated. So basically, all these techniques are applicable for certain application. All these are, sometimes we may use one of the basic protective measure and one of the fault protective measure. Generally, the measure which we use for basic protection is insulation of live parts or barrier or enclosure inside a premise, inside a low voltage consumer premise, and for fault protection, automatic disconnection or extra low voltage. These two are made. Of course, separation is also made in some cases. So the auditor, first job of the auditor is to understand these safety measures, its application, and he has to find out the applicable safety measure for a given location. Location to location, it varies. If you have a computer, if you have an area with the computers, then sometime you may need to go for a separation. If you have a critical place with wet areas, probably you have to go for an extra low voltage situation. So the first job of the verifier, I'm not saying the auditor, verifier, is to ascertain, or he has to understand the safety measures and he has to apply it appropriate to the location. There are measures sometimes for one measure which offers both basic and fault protective measure. So this is the meaning of the, out of 18 inspection points, the first inspection point is protection from electric shock. The verifier must understand each of these measures, and he has to find out the applicable measure which is applied in a specific location. Now, once when it comes to automatic disconnection, which is one of the safety measure, especially used in AC application, MCBs are used for automatic disconnection. MCBs, there are 3 types of MCBs available: Type B, Type C, Type D MCB. I have put the tripping characteristics of the MCBs. Each of these MCB have got its typical way of disconnection, especially when it comes to instantaneous tripping. A Type B MCB, 3 to 5 times the nominal current. Type C, 5 to 10 times current. Type D, 10 to 20 times current. So basically, these 3 types of MCBs must be selected appropriate for a certain location. For example, in a residential application, MCBs are to protect the wiring of the installation, not to protect your equipment, but to protect the wiring of the installation. Now, in a residential application, in the distribution, especially in the final circuits, we are supposed to use the type B MCB. Type B MCB is more safer because it can even trip instantaneously at even a lesser current. Even this means even if the impedance of the circuit is a little bit higher, this MCB is efficient because each of these instantaneous tripping current is related to the impedance of the circuit. So MCB, type B MCB is very much necessary for residential application. Of course, for industrial, it's a little bit different. But whatever the MCB type of MCB you use, you have to size the conductor accordingly, and you have to have the impedance accordingly. Number two, copper conductors used in conduit wiring. You know very well conduit wiring. I spoke about this subject several occasions, not now first time, several occasions. Copper in the wire generate heat. Once when we pull the copper wire through an enclosed space, such as a conduit or such as a trunking, the amount of heat which can be generated inside this confined space must be limited, not more than, say, for example, not more than 70 degrees. If the temperature is going more than 70 degrees, you end up with trouble. Now, the IS 732 has included filling factors, derating factors, voltage drop calculations, and several factors with which you can select the appropriate size of the wire. For example, the wire manufacturer may be claiming that 2.5 square mm wire can handle 20 amps, but practically in your building, you have to use it only for 10 amperes. You cannot use it for 20 amperes because you are pulling it through a conduit, multiple wires are there in the conduit, you have to derate it. These derating factors are very much given in the standard. So, electrical safety with respect to wire, there are two things. One is what happens before the fire. Next is what happens after the fire. After the fire, insulation is important. The insulation must have very, very limited smoke density, or in the other sense, the visibility must be much, much higher for a safe installation. Before the fire, conductor resistance is important, heat, because if the resistance of the wire is high, more heat is produced. In that particular case, wires are classified into class 1, 2, 5, 6. Class 2 and 5 are flexible wires. All the calculations in the standards are made based on copper conductor class 2. Now, I am showing class 2 and class 5. Class 2 is a copper wire with lesser resistance, 8% or 9% lesser resistance. Class 5 is a copper conductor with higher resistance. This means class 5 wire with higher resistance is more dangerous in comparison to class 2 wire. All the calculations are made based on class 2 wire. All the conduit wirings we are supposed to make with a class 2 wire. Unfortunately, both class 2 copper wire and a type B MCB are not available in the market. I repeat, for a safe installation, class 2 wire, I am talking about the smallest wire which is used in our house, class 2 copper wire, and type B MCB are not readily available in the market. So this is the actual fact of the installation. Now, I would like to stop the presentation with this. Thank you very much. We will go for a small question answer session. Hope the presentation was.
Yeah. Should we invite? We have invited 4 of our members here, sir. Would you like to take up the invite them to talk?
Yes, yes. So I made at the final slide, I made a presentation. I made a statement that the wire which we use, class 2 wire is not available. Type B MCBs are not available. Now, along with us, we have Mr. Riaz Ahmad Qazi, who is one of the 5 chartered electrical safety engineer passed out from Maharashtra State Electrical Inspectorate. We would like to invite Mr. Qazi. Mr. Qazi, we would like to listen to you about your experience in the electrical safety situation.
Thanks, Gopal Kumar sir, and good morning, good afternoon. Thanks for giving opportunity. As far as electrical safety is concerned, I need to share that in industry, normally electrical safety audit is normally do as per the recommendation from the factory inspector or the electrical inspector of or the fire department for the sake of the for the doing. And normally the electrical safety audit what normally done is a walkthrough audit and general recommendation like rubber mat not available, earthing not checked. The general housekeeping related observation normally do, and as far as the requirement as per standard is not followed. And the main, I think the main issue is the awareness. As Gopal Kumar sir is already mentioned that the copper class 2 copper wire, I tried to search in Pune market. So class 2, there is no awareness about a good OEM or the good wire manufacturer. They're not able to differentiate between class 2 and class 3 wires. And similarly, I tried to find type 2, type B MCB, and I talked with a couple of well-known manufacturers. They are saying that normally type B MCBs are retail application. You can say some specific areas or specific residential normally installed. Type 2B, they're not able to give the justification or do the clarification technically what tripping time. And normally they say that if we install a particular type of MCB or RCCB, there is a tripping, and they're not able to address why they get tripping. Instead of they change the MCB type. That is not a good practice. So as far as audit is concerned, I think we need to address as per the industry. For a building or the government offices, we should have a different kind of audit procedure. And in the industries, again, the industrial, we have a different type of industry as per the risk. In my opinion, I am following NAP 70 from last 10 years. And in electrical safety, there are 2 type hazards we need to address. One is the electrical shock hazards, and there is a electrical fire hazards. So we need to have a proper checking mechanism or the audit mechanism to address. As Gopal Kumar ji rightly said, we should have a good checking mechanism during installation and commissioning, because once we do installation and put to in the circuit, then we're not able to disconnect on the sake of the testing or the verification. So whatever the verification we do during commissioning, that is a very good time. So after that, checking and verification will become difficult.
Thank you very much, Mr. Riaz. Thank you very much. We have Mr. Sanjay Mulai from one of the largest agricultural companies in India. Mr. Sanjay, you are following a lot of our webinars. We always see your name, but we never had an opportunity to speak. What is your experience in the subject question?
Yeah, thanks Gopal Kumar for giving this opportunity to speak on electrical safety. I'm working as a global principal engineer for whole Syngenta sites, and we have, presence in almost 200 countries. And I get opportunity to see all the regions, like from US till Philippines, APAC, and China, EME, Africa, everywhere. And one of the important thing which you spoke, I think, I keep a thing that electrical safety starts from the design stage itself. And when I'm interacting with the consultants, either in Africa or in US or in China or APAC region like Indonesia, Pakistan, Bangladesh, I'm finding that the concept of earthing, like what you said, TT, TNS, IT, still it is absent. Second thing is that people doesn't understand, between the exposed protective earthing and extraneous conductive earthing. Still that concept is not understood very clearly. So what I'm finding that when I put in the design, they said you need to really thoroughly look into the IEC 60439 and talk about the grounding. Bonding is very important, and I'm giving more thrust. In fact, I used to start a word saying that if you don't take care of earthing, earth will take care of you. Like that statement, I start my training sessions and everything. So my experience is that the absence of IEC and the concept of earthing is very still not gone to the across all the regions as well, and people need to be educated on that. And after hearing your seminar from last 2 years, I have done my electrical, instead of I said like safety audit, I said yes, assessment or verifications. I know I made a lot many difference in my checklist, and wherein now like fault of impedance is one of the important, which I inducted into that, and I'm started doing across the regions. And it really finding that it is being helpful for the other peoples. And apart from that the equipment like AFDD or SPDs or the global earthing system, that also we started inducted into this our checklist. I'm discussing with every consultant in other regions as well, and I'm finding that I'm improving a lot. One of the another important thing which I found that, as you rightly said, the coordination between the wires and cables and equipment load and the MCB absolutely absent. Example, when I go for audit, I just check that okay, you have one equipment like it is carrying 2 ampere current and its MCB of 32 amperes. Then I said, how it is going to trip? The whole thing will go into fire, and the thing will this won't trip, and over and above, there's no proper grounding, sizing also not there, absent. So there's a lot of gap, not in India. I can share you because I worked with other regions, and I say that it is a tremendous gap in understanding the load coordination. I refer IEC 603649 or IEC 620305 because the concept of ESC and CAC was going earlier. Then I stopped IEC using the CAC and ESC. I said, you go do the proper risk assessment, whether we found out the risk calculation, whether is it necessary to do the lightning protection, what size of lightning protection, everything has to be done as per IEC 62305. So lot many things, Gopakumar, we learned from your sessions and did lot many improvements on our checklist, and it is really getting useful because I'm finding that the consultants are listening now. They started saying,
thank you,
which is happening now. I think that's what I want to, because we have limited time, so I could able to share something experience which I had with in my industry. Thank you very much.
Thank you very much, sir. Thank you very much, sir. Thank you. Thanks for your comments. We have one more gentleman whom we invited to have share his knowledge, Mr. Jerome Lobo. He was in the industry for more than 30 years, retired recently. Mr. Lobo, we would like to listen to you.
Hi, good morning, Mr. Dominic and Mr. Gopakumar. Thank you for giving me this opportunity. Like Mr. Kazi said, I too went, and checked for this type B MCB and also for the class 2 wires. In fact, some of the reputed shops in Goa, I checked in 2 cities, and both of them, first they were not aware of class 2 wires. And then when I said I said it'll be written on the coil. So they went up to the coil and they said, no, this is class 5. So I said, I want class 2. So when I asked them for class 2, they were a little puzzled. Then they said, no, we'll get you give me the order and we'll get it for you. So I said, why can't you give it to me now? He said, no, sometimes we don't have the colors, we don't have stock availability, so I'll get it. But he didn't want to say that he didn't have it. Similarly, I went for MCBs, type B MCBs. I checked with 2 reputed brand, which sell reputed brands, and both of them had only type C MCBs. They said, if you want, I can get it to you within a week, but this is normally project requirement. It's not this thing. But if you want, I can give it to you. And coming to the audits, like you said very correctly, The audits are more of a sampling, whereas you have to do a verification. In fact, when we used to do audits, it was more like you said, some sampling thing, and we would check like things like earth pits, we check lightning arrested tests, we would check oil filtration, check ACB servicing, we would check thermographic, load testing, interlocking, previous audit points, whether they were cleared, load balancing, health of insulation, HERA, double earthing, LOTO, training of people, calibration of tools, single line diagrams, permit works, so these were all the things that we would check, which maybe are necessary and are good. But the basic, like you said, the resistance of the cable which has been put there, have we verified it or are we checking it? And will that actually prevent the fire or prevent the MCB or the protective device from tripping? I think that's one thing that we miss in all these audits. And like you said, it's more, we have to do a verification than an audit. Thank you.
Thank you. Thank you very much, Mr. Jerome. So we have Apau sir. Apau sir, can you share your experience, or you are on mute?
Thank you. Good morning, Gopal and Mr. Dominic. Very evening session. So you have covered important areas. I would like to limit to 2-3 previous experts has already explained in detail about the protection measures and audit measures. What I would like to say a few things in this forum is, first of all, inspection for verification. That's a major job, because audit, as you said, audit is not specifically stipulated in any of the codes or standards. But still, I hope that NAB, as National Accreditation Board for Hospitals, they require audit, and most of the consumer installations from MNCs, they require audit. So my purpose, my opinion is, we can use that for sensitizing the consumers to verify all these things, because verification, as you said, is very tough process for each and every thing in a running installation. So what the audit can aim is, it should be a consumer and the auditor interactive. What do you say? The norms should be fixed between the auditor and the consumer. So for which a standard should be evolved. What should be the audit norms? A practically viable audit norms. In my opinion, the initial design itself is not coordinated. Whether they take into account of fault level, your power system analysis, or your power quality issues that crept in the later stage, which can infest the installation with power quality issues like low frequency and high frequency noise setting, which ultimately affect the performance of sensitive components. Like, for example, an echo machine, it can malfunction because of these issues. So the audit can concentrate at the initial observance, whether the consumer has observed all the design aspects initially, whether they have done verifications initially. The audit team can check measure few samples, because it will become a Herculean task to check each and every aspect. So they can be the audit team can be an empowering knowledge sharing person to the engineers in the premises, in the facilities. Number one. Another thing, of course, earth resistance and the thermography are also not mentioned in the specifically mentioned in the standards, but it requires in certain locations. For example, a bus bar heating can be transmitted to the wire insulation. But what people use, the thermographic instruments are not reliable. It depends on various factors, conductivity, emissivity, everything. And as a result, the resultant is a failure. It will be creating a very concern to the consumer. They will be fearing, oh, my bus bars are heated up to 120 degrees, but the cable can stand up to 80 degrees. What is the point at the cable, whether your measurement is correct? So ultimately, the purpose of verification is by by wrongly interpreting these things. Another thing, type 2 coordination. It is totally missing in all the institutions. People are having a concern over the type 2 coordination, availability of conductors as well as especially beacon MCBs. For example, in every domestic premises, for example, if I have a 1.5 kilowatt geyser and I have to select based on the design current of 7 amps, I have to select 10 amps MCB, but I have to use 4 square amount cable. Then only it will be compliant. If I use a C curve, it is not possible. You have to provide a 6 amps, 6 square amount cable, which is very tough. So people do not observe 100% of installation. I can certify that type 2 coordination is missing, except very few places. In domestic premises, totally missing. The absence of B curve MCBs is also adding to the fire to the fuel, and it is driven by the marketing mechanism. The manufacturers will always tend to produce more on what is the availability, what is the requirement. So it is a feedback and a driven mechanism. The electricians and the consumers are not aware. They have to play a major role, and the enforcement mechanism should also have to play a major role in fixing these issues. So these are all my opinion, and I would like to
Thank you very much, sir. Thank you very much, sir.